It's just another slightly, well, close enough. So when we started working on SAPRI, initially Danny Adams, the late director of PSI, the father of the South African research infrastructure roadmap, told us, you are going to cater for the science of the future. I know you're interested in keeping your science alive, but actually I want to invest in the science people will be doing when you're not around. That's what we've been thinking. But I would like all of you to get rid of your natural scientist hat. You know that you like to be in the island, in the remote, doing your own science, but we live in a society. We live in a complicated society. And actually, when coming here last Tuesday, I was driving on the N2, and then was going off away from Cape Town, and then there was a very long realized infrastructure. There was just a long line of mini taxis. And then it was 1.5 kilometers of mini taxis. And then I realized that actually infrastructures are planned in a certain way, but then they are realized in a completely different way. And if we have to explain the reason for polar infrastructures, we have always to balance and get rid of our natural scientist hat and think how it balances, how it combines, and how what we do is embedded into the society we live in. So how would I explain the importance of investing in any infrastructure when actually there are very little infrastructure in Africa in general? How do we do if we have just 20, 30 seconds with any ministers? That the minister would listen? How would you explain all this? So how do you bring something that is so distant close? By connecting different concepts. And actually sometimes this concept can be the most absurd you can think of, which is why what I'm presenting now is not just the polar level, but it's more than that. And the idea is to cross geographical and social divides through infrastructure. So through creating infrastructure and catering for what people would want to develop in the future. So I've been using this slide to present the idea, the concept to a variety of people, mostly from business, society stakeholders, and others that know nothing about polar science. They actually don't even know where and how it looks like, because the projection we have in mind is a flat projection like this one, where you don't, and it's zoomed if you actually look at the whole globe where Greenland is huge and Antarctica doesn't exist. That's not the Earth. Even if we got access to so many new tools, still we don't understand geography, and the geographers here, I'm pretty sure they agree with me. But we have no idea of distances at all. We have no idea of divides and how relevant they are. So we have to communicate. When you're talking about your science, do that effort all the time. Do that effort in talking. That's why we are showing here the complexity of measuring anything in the African continent when compared to our region of interest. And the maintenance of infrastructures and the decision making related to those infrastructures is of high relevance and has to be communicated. Stefan just said, if we didn't have engineers awake and available in infrastructure, we would have missed many things. How many data have we been missing and would be helpful for taking decisions? So the rationale, and you say, where is the polar land? The rationale comes from very far away, and it's actually the most relevant thing. And it is urban at the very end, because we work in an urban environment, and paradoxically, they are merging together. Well, apparently kind of get closer. You have heard that we now can have a Boeing, very large Boeing, bringing more scientists to Antarctica. It's a corridor that we want to have, and apparently that will become closer. But paradoxically, at the very end, they are becoming more distant. So urban spaces, pristine spaces, are effectively more remote and less accessible. It's far more difficult to get data from a township than it is to get data from Antarctica. And this paradox is winning somehow. It's clearly brightening and making people think outside the box. So we have major challenges to deal, and they have been ratified, explained. We have a concept like the Sustainable Development Goals. We all try to fit into that. But at the very end, the convergence of these challenges will have to be dealt with through a combination of renewed, rethought digital technologies. So you can't talk about any physical measurement of something without its digital equivalent. That's why we've been talking about digital twins for quite a lot. Lots of people don't understand it, they kind of abuse that concept. We're going to use it the right way here, which means making sure that something physical has a digital equivalent that is reliable entirely. But all of that can be used in a different way. Like, we all know the challenges we have, and they are grand socioeconomic challenges. We have problems with infrastructure delivery, management of these challenges, and all of this has to be embedded into sustainability and climate change risk. And associated to each one of that, we've got problems. Funding, aging infrastructure, rings a bell. Related to power plants, for instance, that's one thing. I don't have to explain this. Actually, the best explanation of an anomaly I've ever heard about the poverty and someone that is receiving the money at that moment. You need to look at longer term analysis to calculate anomalies. It can't just be one single, very interesting burst, but that works in astrophysics. It doesn't really work on this case. The problem with sustainability and climate change risk are the increased incidence on extreme events that are local but are external to us. They are very remote. How do you explain these remoteness to people? So basically, at the very end, someone has to take the decision. We go and ask for money, and we have to explain why we want the money in all this arena, which is very complicated. So prioritization, balancing cost, level of service. At the very end, that's where we have to operate. And we have to operate dealing with something very distant. Is why should we care about Antarctica when Africa is dodging, balancing, dancing, falling into those pitfalls up there? Well, this is nothing new in a way for many scientists here, but that's where we stand. It is extremely likely that we're losing ice from Antarctic ice sheets. It is, we have high confidence that the oceans have been continuing to warm, and the Southern Ocean has been warming the most, have been capturing the largest amount of heat of all the one ocean we have, that portion. And you've seen this picture from Sarah presented yesterday. However, we have very low agreement on why the hell this is happening differently with the Arctic. The Arctic is clearly showing what Arrhenius told us more than 150 years ago, 1887. He predicted that the polar hemisphere were likely to heat the most. So that's really no rocket science. If the science from 150 years ago was sufficient to explain what's exactly happening now, that's one thing. But the southern hemisphere is not showing this polar amplification at all. And we don't know why. And in our models at the very end, they have very low confidence. And how can you explain to the people that something you don't understand is still a risk for us? It's an important risk. We have to have that perception, because that is helping to have decision. So this is just to convince you that that's what's happening. This is the mass change loss from Antarctic ice sheets. And when compared to Greenland, Greenland is losing a lot more than Antarctica. And apparently, at the moment, we have already committed approximately 274 millimeter of sea level rise, according to the last 20-year changes in 20 years. So it's a lot. Just 7.6 millimeters you have seen, according to these calculations, but the commitment is much larger than that. Antarctic sea ice has been showing this kind of puzzling, complex cycle that is difficult because of this large seasonality. It is very much the largest seasonal event we have on the Earth. So it must be affecting our climate. How do you explain all of this properly? It's difficult because you don't see it here. You don't see it in Africa at all. You understand a lot more about those consequences, probably in Amazonia, because they know very well that the weather sea ice is affecting the precipitation conditions in there. And it does something similar to here, but Southern Africa is more complex because of the Indian Ocean and Atlantic Ocean combination. So that's where we need a lot more convincing studies to that. But at the very end, what happens is Antarctic sea ice, with respect to the Arctic sea ice, so this is thermodynamic winning. Low troposphere getting warmer and warmer, that's what happened. And this is where we are now. This is 2023. 2023 is 5 standard deviation away from all the other years. And this is the anomaly, the Antarctic, again, thanks so much for explaining anomalies. Very good. Now they are all understanding. This is the anomaly, and you can see that now we are heading into a negative anomaly, but we had a positive anomaly. So what if now the system is just starting to oscillate over a 7-year period? We actually don't know. We have no idea about that. The fact that the Arctic Ocean is predictable is because we have made it predictable by changing the heat distribution on the Earth system. So why do we care about ice science? What kind of ice science we can do? There's a lot, and I will speak about it. This is what you have seen on the first day, but the point is, all of this cannot be done by as many people as we would like, because it's not familiar. Not at all. None of us is familiar. Well, unless you have some link with Northern Hemisphere, none of us is familiar with ice. Well, also in your GMT, you may be familiar with ice, but not natural ice. So that's the vision of the digital and polar lab, which is we want a northern space facility that hinges on sharing and interdisciplinary work. And I've been talking already why it has to be interdisciplinary, even transdisciplinary, because we have to bring in the society into everything we're doing. It's not just a conversation among scientists, it's more than that. They are conceived as physical local spaces, but they increase the proximity to remote spaces. And how they do it? Well, of course they will allow better decision making, but that's a long way, because I understand if you're not being trained in making that translation, in making that connection, and I'm not talking about the social scientists among you, because they may be more trained for that, but natural scientists aren't. They have been trained to speak their language, not other types of language. But you are all clever people, so you can definitely do it. So we want to bring the distant near to make it more familiar, to have more people understanding how that component that is far away from us is effectively affecting the functioning of a much larger system. So the remote SANAP, the icebreaker, the township in Gauteng, rural village in the Eastern Cape, all the points that I've been talking about earlier, they can be brought closer thanks to digital technology. And they can be redesigned exactly with the same technology that you may be using for processing signals that are being transmitted from one portion of the land to another portion of the land. That is exactly the same technology. It doesn't make any difference. We are probably using the same methods, because that's the science that has been built a few years ago. FFTs, phosphorate transform, they've been spoken, so you heard it so many. This is nothing new. I mean, Fourier died quite a long time ago. So the point is, this is going to allow us to recreate peculiar spatial conditions that we can then recognize in the future. So how do we implement all of this? All right. This is an example of the divides, of the distances. These are the components we would like to bring in, and it's not just the polar lab. The polar lab is one component of it, But we think that we need development of digital sensors, we need visual and analytical laboratories, we need extended reality labs, because we need to make the distant near. And that's what Ria has been talking about. I can make a virtual digital museum, but it can become a lot more immersive than that, simply by tapping on the technology that others have been developing for an entire different field of science. But we are in a remote region of a continent, big continent, so we have to count on our own resources and combine all of them together. And then everything we do can be laboratorized, can be made like whatever you're talking about, any work that could be done on processing of fluids, on processing of sewage. Well, why not using it in Antarctica then? Why having to rely on technology that is being imported? It's extremely expensive, and certainly someone else has been building that component already, or there are ideas being there. So why not recreating a living laboratory for testing all of that? The vicinity of these ideas generation is likely to engender all of the applicability. So the Polar Lab is a lot of work, and they just be there to be for people to read, and particularly because this is what we also give to interested donors. They are interested in the first laboratory for conducting experiments in Africa, sub-zero experiment in Africa. Well, of course, because there's no other way for us to experience. You can't just take a student and throw him on the ship and hoping that he will be able to collect things properly. Those of us who've been trying to train on a ship, they know how difficult that is. So we do need to start creating those spaces. They can't be everywhere, they can't be in any lab. So having it closer to the ship is the simplest solution we can have, so that's why Cape Town is here. But that can be a resource for everyone. This facility can do a lot of things. Experiments with specimens from polar ocean, subantarctic islands, Antarctic continent, artificial sea ice creation, testing and analysis of physical, mechanical, and biological properties of ice, cold storage, not just for ice, but also for geological samples as well that they need to be maintained in certain conditions. Development and testing of autonomous observation platforms and suitability in extreme environments, calibration of lidars as well. How do we know whether they would be resisting? I mean, we tested one Swift buoy, which is from the University of Washington, in winter, and it froze in just 12 seconds, because it hasn't been created for those conditions, because they didn't think about the defrosting. So we had to recover it. And it's still, lucky enough, it's still measured what we wanted, but finding it was very difficult, because the antenna was completely covered in ice. So we had 20 people looking on deck, looking for that. That took quite a lot of fuel, put it like that. And finally, the digital laboratories that would allow all of this to come together. So these are the accommodations that we've been thinking about, and it's quite many. The ones in blue are all modular, and the ones in green are fixed structure. And with modular, I mean, they would have their own power system. So they can be powered separately and cooled down separately from all the rest. So you can switch them off. You don't need to turn on everything. You can replace it. It's broken. You take it, you bring it away. It's a modular component. Steel is more expensive than concrete, of course. It's going to cost more from a capital cost viewpoint, but from an operational viewpoint, it's going to cost less. And from a functional viewpoint, it's going to be great, because the same laboratory that you're using on land will be on the ship. Exactly the same one, the same equipment. And the crazy people, engineers working with me, they would like to have a vibrating platform, and you know that, we've been already working with vibrating platform. But what would be if we could test if our equipment could resist the same vibration of slamming? I mean, that has been measured. We have the pulse of slamming, but that could be given to a very expensive vibrating multi-dimensional vibrating platform, but then you would have an instrument that is tested before going on the ship. It's 40 million rand more, but we'll come to that. So this is the kind of stuff that was not supposed to be here. Not all of it, but only that one. So focus on that. Just don't look at the rest. Only that one. This is the deck, the operating deck of our ship. All these containers is what we have. So this is an example of how they look outside. This is how they have been designed by TK and team with new polymers. So all of this is one of our process lab. It's DNV compliant, so it's ready to go on the ship. It costs twice the cost of a normal container, of a normal lab container, because all of that. Together with our first environmental simulator, I can't open it for you because it's secret. You can't see what's in it. You will have to guess what's in there. They are currently being built by Polymetrics. They will be delivered May 2024. The environmental simulator is meant to have controlled reconstruction of temperature and light conditions, which means you can set a daily cycle. You can set a combination of daily and seasonal cycle. Of course, you will have a much longer experiment if you want to deal with the seasonality. It will be controlled in the sense that you will have an external camera that's why I can show it to you. You will have an external log camera with all the sensors that are measuring, and it's a digital twin, because you can be now in Salt Lake University and looking at what's happening in the lab without you having to come down to the lab. That is what digital twinning is. Maybe not real time. 15 minutes later, everything is there, but that is possible. So, let's go to where we would like it to be. This is Upper Campus. This is now a parking lot. We would like to get rid of parking lot. Unfortunately, the City of Cape Town tells us that any building will require additional parking lots. They don't really think into the future about it. That's why we have this long queue of mini taxis. A new type of train, actually, because of that. But we have been kind of clever. I'll show you why. This is how it looks like at the moment. That's the entrance of the engineering building, new engineering building, which is already old. And this is the proposed building footprint. We still want to retain that axis there. So we have to be clever into building it. And where is the idea coming? This building has to be built with a cold core, not with a warm core. And the idea that the architects had was, well, let's carve it from the inside, the same way an iceberg is being carved. So that's why you see these Antarctica. It has to have the kind of shape of tabular iceberg, and it is being carved inside and showing the cold core. And down in the cold core is where we can demonstrate the science that can be done in Antarctica in cold conditions. What you see out there is a solar control panel which can be orientated, so we can get, thanks to the engineers, we can actually get to a green building. I wouldn't say zero. It's impossible to have cold conditions here with zero cost, but certainly reducing it to a minimum. That's one rendition of it, one possibility, how it would look like. We have several ideas around it from the back. Very small window, of course. You don't need to look outside, you have to look inside. This is an idea of when you get into there, then it would open up like a big cave and show you the marvelous that you can have in distant places. Not just the polar, but a combination of distant places. The ground floor, this is the atrium. This is a showcase. People will enter for the very first time in UCT live. We've been convincing them to have a public entrance from the outside and not an entrance from there. They were shocked, I can tell you. No, buildings, you can't enter from that side. We wanted them to enter from here, a very tiny entrance that opens up into big atrium. And the big atrium is showcasing everything that can be done with screens, as well as physical evidence of the cold core, and I'll get to there, our wave ice flume down at the bottom. So these are all glasses. This is the zero line. That's where room conditions are separated from some zero conditions. Not all the floors are zero conditioned, but we have to make sure that there is a clear insulation. And this is challenged from an engineering viewpoint. The first floor is dedicated to extended reality office. Some offices, actually the only office here, actually it's not here anymore. We removed all offices, so no one. And the nice thing, and that's how we got rid of the parking, is that no new people will stay there, besides those who are doing the experiment. No new offices, guys. No one is going to sit in there. So you can think about academics, they wanted their own space and all the rest. But we said, well, actually it's not going to host new people. You will have to have people brought in, but you won't have many people every day coming from Cape Town with a car. Then we're going on to the second floor with seminar room, and again the shared office for people working there, only for the period that they're working there, or for extended periods, it doesn't matter. There is a big, this on this side, this black one, there is a big green wall, and the green wall is maintained by the water that is being recycled down in one of the laboratories. So because we have this big tank, then the water will be made available and recycled. And we don't have that technology ready. We just have to show that it can be done. And everything is visible. What is visible as well are all the bathrooms. All the pipings and the bathrooms will be visible on the outside. And I'll show you an example of that when we get to that. And we want them to be reconvertible and adjustable. Because if you want to test a toilet, why having to, we just want to plug it out and put in another one. So that is the idea of living laboratory. We go to the third floor, which is more visual and analytics, digital sensor. That's where people would go and see Antarctica as well as walking through other remote spaces, urban spaces that we want to observe. Let's get to the basement now. The upper basement is where we have this example. This is how it's already working. This is another building like this. This is in Switzerland. Everything is externally connected to the water hub where all the waters are recycled and separated. We can make bricks from urine. So we want to make that separation, and we want to work with that one. And those bricks can be the ones that we're taking down to Antarctica for the building of the future, for the new base of the future. There is some, this is where some of the parking has gone, but this is what is of interest to all of us, and this is my last two slides. Oh yeah, I have the money thing, but I don't. This is the lower basement. At the lower basement, you have this decently long wave ice flume and all the connections with all the modular laboratories. These are the same containers that would then go out and back into the ship, or somewhere else in the field. Or if we want to showcase polar science in Gauteng, or in Eastern Cape, or in Northern Cape, we can take it and take it there and show exactly the kind of work that can be done with the same laboratory. So that's why we need some redundancy. At the moment, we cannot afford redundancy. We can start with 1, 2, 3, 4, and then we will be ready for going at that stage. So the sub-zero, this is an example of how it looks like. I mean, this is the big alto ones that you have already seen in some experiments. This is huge. We're not aiming at that. We're aiming at something like this one with a wave maker, a beach. This is a fake beach which is absorbing the waves. And then here is where the ice can be formed. And we haven't been thinking about it, also to have a current generator. You can do biological experiments into this flow, river flow experiments by changing the temperature. That's how much is it going to cost? Not much. Well, in relative sense. This is approximately, the construction is approximately in the order of 150 to 170. You got professional fees and you got operating and energy costs. That was a stumbling block in many cases. I'm not going to show you. We've been working with some operating consumption. There are very few sub-zero laboratories available. Instead of big ones like the one at Alto, they don't really help. And actually, apparently they don't know how much they are consuming because someone else is paying, and it's also in the northern hemisphere, high latitude. While in our case, we're going to deal with African conditions, not the worst ones, but still quite warm. But there's plenty of research on making all of this efficient. For instance, for reefer container shipping market, there we can tap onto that. So that's the delicate imbalance where we are at the moment. On the build side, we got UCT approval, ESI approval, SAPRI very happy, of course. But on the weight side, we have the Department of Higher Education and Technology that is supposed to be funding the building. Large component of the building, more than 50%. We got a few donors aligned, waiting, happy to put their money into that. One important point, and unfortunately neither Gilbert or Tracy are here, we were talking to business people. Actually, business people are not going to invest in capital. Show me the capital investment, I'll give you the money to keep it running. That's what they're going to do it. So if we put the initial amount for the capital investment, then they will come board. You need to have, they told us, do we need to explain you how business planning works? You need to have a two-pronged approach. You build your own capital investment on the one side and ensure that the running costs and the future maintenance are flowing through private and industry donation and industry participation. And that was actually easy. We got many companies interested immediately, but they said, well, I would like to walk into a building. I walk into a building and then I give you the money. And they said, I'm really going to give you the money. I'm not just saying this because I want to find an excuse. It's serious. So this is where we stand at the moment. And that's where I really would like to end. So thank you so much.